Bismillahirrahmanirrahim. Today, inshallah, we'll review the basic trigonometric ratios. We have talked about these briefly and in geometry, and this will be a review of the Sukatoa stuff and basic trigonometric ratios. If you recall, in geometry, we derived these from a right triangle, and that's very, very important. So the triangle I drew over here is a right triangle. And as you also recall from geometry, that the vertices or the endpoints of segments here, the vertices of a triangle are labeled with capital letters, and the sides opposite of those vertices are typically labeled with lowercase letters, such as side opposite of A. Opposite of A is A, correct? And the side opposite of B is the lowercase b, and the side opposite of C is lowercase c. And if you recall also from geometry, we have the Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the two legs of a right triangle and c being the hypotenuse. So a squared plus b squared equals c squared from a right triangle Pythagorean theorem. Now from these also we shall derive our trigonometric ratios. So the A here, you can call it angle A or alpha, so we'll go with angle A. So if you recall, so, or just so, ka, toa. Now this mnemonic had helped us memorize the basic trigonometric ratios of sine, cosine, and tangent. So let's start with angle A. Okay, so sine of angle A was defined as opposite over hypotenuse, and cosine of angle A was defined as adjacent over hypotenuse, and tangent of angle A was defined as opposite over adjacent. Okay, now these are not zero, of course. This is just a way of remembering sine, cosine, and tangent of angle A. Now you also understand that opposite, these words opposite and adjacent are in reference to a certain angle. So what's opposite for A is not opposite for B, right? So this is opposite for B. So little b is opposite of the angle B, and little a is opposite of angle A. In fact, the side A is adjacent to angle B. So opposite and adjacent, these are terms that are in reference or that are in association with a particular angle. So in this case, sine of A will be opposite over the hypotenuse, right? So it would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent, like this. So as an example over here, I have a triangle, 3, 4, 5 triangle from the Pythagorean triplets, if you recall. 3, 4, 5 was Pythagorean triplet, right? So 5, 12, 13, 7, 24, 25, 8, 15, 17, those being the other Pythagorean triplets. So 5, 12, 13, 7, 24, 25, 8, 15, 17. These Pythagorean triplets, you must know. Now, I call them triplets. They're really not triplets, right? Because they're more like Pythagorean triples is what they're really called, okay? So these Pythagorean triples you have to kind of know, okay? So in this regards then, we can say sine of A therefore be opposite. So if you just take a moment to just write this on the top of the page, if you're not comfortable with this, it helps you quite a bit. I've noticed that for myself. So sine of A is opposite over hypotenuse, so that's that's the opposite side. So that would be 3 over 5. So cosine of A would be adjacent over the hypotenuse. That would be 4 over 5. And then tangent of A would be opposite over adjacent. Okay. Now also then let's do the same thing for angle B. So sine of angle B is OH, opposite over hypotenuse, 4 over 5. Let me write these over here, adjacent. So sine of angle B is opposite over the hypotenuse. Cosine of angle B is going to be adjacent over hypotenuse. And finally, tangent of angle B is going to equal to opposite over adjacent. Now, if you just observe these over here for a moment, okay, what do you recognize over these? Okay, look at this. Sine of A is 3 over 5, whereas cosine of B is 3 over 5. And then we have cosine of A is 4 over 5, and then sine of B is 4 over 5. In other words, sine of A is the same thing as cosine of B. So sine of A equals cosine of B, and cosine of A is the same as sine of B. So this is an observation you can make for any complementary angles, as long as A and B are complementary angles. There's not only are their sines and cosines are complementary, basically, right? So this is how SOHCAHTOA are originally defined for us. Okay, so today we shall learn 3 additional trigonometric ratios which are related to these. Okay, and these are reasonably easy to learn. So sine of A is defined as this. Okay, opposite of hypotenuse. Okay, inverse sine of an angle. I'm going to skip the angle here. 1 over sine of A. Okay, I'll just write it. Inverse sine of A. And then there's another one that's defined using inverse sine of B, or the flip of the cosine of A. And the third one that's also defined using flip. In other words, you make the reciprocal. Okay, 1 over tangent of A. So there are 3 other ratios that are just inverse of these. Okay, so inverse sine of A, or 1 over sine of A. Okay, this is called cosecant of A. Okay, so cosecant, S-E-C-A-N-T, cosecant of A. Okay, and 1 over cosine of A, or inverse of cosine of A, is going to be secant of A. This is S-E-C-A-N-T. These are just another bunch of ratios also, right? And then 1 over tangent of A is cotangent of A. Cotangent of A. Okay, so these are 3 new ratios that we have to learn. So 1 over sine of A is cosecant of A, and 1 over cosine of A, or A being any particular angle, is secant of A, and 1 over tangent of A is cotangent of A. Okay, so I'm going to do an example of this over here. So let me just erase all of this so we can start from the beginning. Okay, so let's give ourselves a triangle to work with. Let's give us a 5, 12, 13 triangle, okay? So let's write down the 6 basic trigonometric ratios, okay? So we're going to talk about these. These are going to be the 6. So let's just do the first one. So let me, to help ourselves. SOHCAHTOA, right there. All right, so let's start off. So sine of A, what is the sine of A? Opposite over hypotenuse. This is opposite over the hypotenuse, which is 5 over 13. And cosine of A is, if you recall, adjacent over hypotenuse, right? Okay, so cosine of A is going to be 12 over 13. And then tangent of A is TOA, opposite over adjacent. Opposite over adjacent, which is 5 over 12. Now from these we also get the other 3 related ratios. 1 over sine of A is going to be cosecant of A. Now the way I remember from when I was in high school is that if it starts with S, this one starts with C. Okay, if it starts with C, the other one will start with S. Okay, so cosecant of A, okay, cosecant, it will be inverse of this one, so it will be 13 over 5. Okay, and then 1 over cosine of A is going to be secant of A. Okay, and that's going to be the flip of this one, so it's going to be 13 over 12. All right, and then inverse tangent, or 1 over tangent of A, is going to be cotangent. Okay, that's going to be 12 over 5. Okay, so now look, as I said, if this one starts with S, this one is cosecant. Sine, cosecant. Cosine, secant. Tangent, of course, cotangent. Okay, that makes sense. So these are complementary. And also, okay, so these are the 6 basic trigonometric ratios. Okay, I have also humorously before suggested to you that sine of an angle, gerene, okay, over cosine of the angle, let's call it gerene, okay, and I had suggested to humorously that this equals of tan of gerene, okay, or tangerine, right? But this is true actually. The sine of an angle divided by cosine of the angle is equal to tangent of that angle. This is a property, okay? And this is easy enough to demonstrate even here, okay? So sine is, right? Okay, sine is 5 over 12. So let's see tangent of it, right? So is it sine is 5 over 12 divided by cosine, which is 12 over 13. Okay, let's see what we get. So 5 over 12 divided by 12 over 13, which is 5 over 12 times 13 over, oh, I'm sorry, I made a little mistake here. It's 5 over 13. Okay, so 5 over 13 sine divided by cosine, which is 12 over 13. There we go. 5 over 13 divided by 12 over 13, which is 5 over 13 times 13 over 12. And then you simplify this and you get 5 over 12, which is tangent. Okay, so this is actually a very important property. Sine of an angle divided by cosine of an angle gives you tangent of that angle. Okay, so in summary, here's what we reviewed today. We defined the basic trigonometric functions: sine of angles opposite over hypotenuse, cosine adjacent over hypotenuse, tangents opposite over adjacent. And today we also learned 3 new trigonometric functions, which were inverse the sine, or 1 over the sine of an angle, or the flip of the sine, is cosecant of that angle. It's called cosecant. And 1 over cosine is called secant of that angle, and 1 over tangent is called cotangent. So these are 3 additional trigonometric ratios that we learned. And basically, you take the reciprocal to generate these. Okay, and I also suggested the sine of an angle divided by cosine of an angle equals tangent of that angle. That is a property worth remembering because it comes handy quite often. We shall elaborate on this next time. Until then, as-salatu was-salamu ala rasulillah wa ala alihi wa sahbihi. Assalamu alaikum.